Hello. So our today's question is okay, is it not visible? Now visible. Okay, so our today's question is minimum path sum. So what this problem said is we have given an grid which is of size m cross n filled with non-negative integers. Okay, so it is filled with non-negative integer. There is no integer in this grid which is negative. So we have to find the minimize the sum of all numbers along its path. So we have to start from its starting position, which is basically 0 comma 0, and we have to go to its final m comma n, and we have to find a path which gives us the maximum value, to reach the endpoint. So you can only move either down and right at any point of time. Okay. So basically, what we have to do, we have to start from this point and we have to reach this point. So let's find out how we can do this question. Okay, let's do this question. So in this question we have given a great, basically a grid which contains the element 131, 151, and 421. Okay, so we have to go from this to this and find the minimum path sum. Find the minimum possible path sum. Okay, so what we can do here is we have to use dp because we have two options, whether we can go right or whether we can go down. Okay, so if we go right, and from right we can go again right and down. So from right, if we go right, we will get a minimum path sum from that point to other points. Okay, so like we have a grid. So when we go right, so we will get a path sum of these elements because these are the only option I left for right and down. Because if I go more right here, so I have only down options. So if I go down from here, I can also go right, I can also go right, and many other options. So what we can basically do in this, we will make a function right. Okay, which basically find the minimum path sum considering it as starting point. Okay, so what we will do, let's suppose we made a function in minimum sum, and what we will pass our grid, our current index. Okay, and when we go right, what we will do, minimum sum grid, we are going right, I plus 1 comma j, and if we go down from that point, what we will call minimum sum grid, our x-axis remains same and we will go down. Okay, and from that position we are checking our right and down, so that coordinate also added and make enhance in path sum. Okay, so what we will do, we will return from here uh, that point value grid ij, plus from right and down what we will get is minimum, we will check the minimum. Similarly, if we are going right, we will find the right and down from that right, and if we are going down we will find the right and down from that down point. Okay, so we will find the minimum of right and down, and what will be our base case. We also need a case which will stop our iteration, otherwise we will go right and it cross our boundary. So we also need a base case. What will be the base case? So if our m greater than if our I greater than or equals to m is basically the size of row size, and our column size is n. So if our I crosses our last index, and also our j crosses our last index, what we will do, we will return int max. Okay, otherwise the other base case is if we are at our last point, what we will return, we will return what we will return, the value of that, because when we were on last second point, the point which is above and which is left to our last coordinate, so we will adding that value to this, and this will return this, and we will not get another calls. Okay, so this is our code, and let's try to code it. So if our index grows the m or j grows n, then we will return int max, because it will not be considered that, and because we want minimum value. Also, if we go right, we will and one. So we are done with this question. We use TP because if we reach to any point multiple times, if we go right and if we go down, and from right, if we extend right, we will reach multiple points, and if we extend down, we will reach multiple points. From that to point, if we reach to a common point, if that common point is stored in DB, we don't need to traverse that point again and again. That's why we will use DP, and it will decrease its time complexity. Okay. So code is submitted, all test cases are passed. So thanks for watching.